Today we shall have a look at the perceptron learning rule. Now in this perceptron learning rule, what happens is that the learning signal is the difference between the desired and actual neuron's response. And we have seen in the previous slide what is R. R is nothing but the learning signal. Now this signal is taken from the output. Okay, and here what is done is that this is O1, that is the actual output, and this is the desired output. So what is done is that the error signal or the learning signal is calculated as difference between the desired output and the actual output. So it is di minus oi, and this di minus oi is multiplied by the learning constant and multiplied by the input vector in order to get the weight adjustment delta wi. So this is what is done in case of a perceptron learning rule. But what is oi? As we know what is oi, oi is nothing but sine of Wi transpose into X. Now please remember, here we are using sine of Wi transpose into X. We are not using f of Wi transpose into X. So it is very clearly known that here we are using the Signum function, and it is Signum function is nothing but used for a bipolar discrete neuron. So the output can be either +1 or a -1. So here we shall note that the perceptron learning rule will be using Signum function, and it is used for bipolar discrete neuron. And di is nothing but desired response. It will be either +1 or -1. Now it is a supervised learning rule. Now perceptron learning rule is a supervised learning rule. Why it is a supervised learning rule? Because of the presence of the desired response. We have the desired response which is given in the question. So we already know what should be the desired output, and hence it is a supervised learning rule. And I have already told you that it is only applicable for binary neuron response, that is bipolar, because the activation function is nothing but bipolar signum activation function. Now in Hebbian learning rule, it was told that the initial weight should be very low, but here the weights can be initialized at any values. So the weight adjustment is as follows: delta wi is nothing but c di minus oi. Di minus oi is nothing but the learning signal, or here in this case it is called as the error signal, multiplied by x. So oi, the value of oi is replaced as signum of wi transpose into x, and again it is multiplied with x. So this is the weight adjustment which we are getting here. So please note here that in place of any neuron, TLU is mentioned. So TLU indicates nothing but a signum function. So it is the TLU is mentioned in this case. So which tells you again that it can only be used for a bipolar binary neuron. So when will the weights be adjusted? The weights will be adjusted when, if and only if and only if OI is equal to OI is not equal to DI. So the weights are adjusted only if OI is incorrect. That is, OI is not equal to DI. So only then the weights will be adjusted. So what we can write is that for a bipolar binary case, di, if di is equal to oi, then what will happen? This learning signal will be 0. So this will be 0, and because this is 0, then the weight increment delta wi will also be equal to 0. So the weight is not changed, neither it is increased nor it is decreased. So no weight update, as desired and actual responses match. But if at all, these two conditions are very important. If di is equal to 1 and if oi is equal to -1, so they are not matching. So expected output is +1, actual output is -1. So when I substitute here, this will be 1 and this is -1, so it will become 2. So this will become 2, the error signal will become 2. So the weight increment will be 2cx. So the weight increment equation becomes much simpler. Okay, so next is if di is equal to minus 1 and if oi is equal to 1. So if di is equal to minus 1 and oi is equal to 1, you substitute here, di is minus 1, oi is 1, so it will become minus 2. So delta wi will be minus 2cx. Is that clear? So this is what we get for a perceptron learning rule. So now we shall be going and solving problems on perceptron learning rule.
Okay, this problem is on perceptron learning rule. So, set of input vectors and initial weights are given as follows. Learning constant is given, it is 0.1. In the previous problems of Hebbian learning rule, we have used 1. Now, what extra information is given here? You remember that perceptron learning rule is a supervised learning rule, and that is the reason we are given the desired response, that is teacher's desired response for x1, x2 and x3. So whenever input x1 is presented, officially or not officially, it is expected that the output O1 has to be minus 1. That is nothing but the desired response. So the desired response D1 is given as minus 1. When input x2 is presented, it is desired that D2 is equal to minus 1, and when x3 is presented, it is desired that D3 is equal to 1. Now this O1 may not be equal to D1 because this is the actual response what you will calculate, and this is the desired response. So desired response may not always be equal to the actual response. So also you are given an initial weight vector W1. Please note in the previous problem I would indicate it as W superscript 1. It is better I thought that we shall represent it as subscript only. So that is this way. Okay. Before we start with the problem, I shall write the perceptron learning rule. That is what is the weight update equation in perceptron learning rule. So delta W is nothing but C, delta Wi it is C di minus oi, and what is this? Di minus oi into x, that is your xi. So what we know is that we have already seen that here very easily you can calculate it depending upon what is the value of di minus oi. So when di is equal to oi, what will happen is that this term will get reduced to 0, and therefore the weight vector will the weight update will be equal to 0. So delta Wi plus 1 will be equal to 0. And when it is not equal, that time delta Wi plus 1 will be equal to what? Plus or minus twice Cx of I. So when will it be plus? It will be plus when, so if at all di is equal to 1 and oi is equal to minus 1, that time it will be twice Cxi, and when oi is equal to 1 and di is equal to minus 1, it will be minus 2Cxi. So this is just for reference purpose. We shall just keep it somewhere so that we know this. So now we shall go to the first step of the problem. We shall start with iteration 1, step 1. So what we do in step 1, we present pattern vector x1. So when we present x1, okay, x1 is nothing but 1, minus 2, 0, 1. This is x1. And the desired output, what is D1? D1 is equal to minus 1. This is the desired output. So first when we present, the first step is to calculate net 1. So we calculate net 1, and what is net 1? Net 1 is W1 transpose into X1. And whenever you take this, W1 transpose is 1 minus 1, 0, 0.5 into X1. X1 is 1 minus 2, 0, 1. If at all you get this, 1 into 1 is 2 plus 3, then you will get 0, then you will get 0.5. So this is minus 1, so it will be 2.5. If at all you calculate, it will be 2.5. Now next is, what is O1? O1 is nothing but f of net of 1, and as you know that perceptron learning rule is only for Signum function. So when it is only for Signum function, we do not have to bother about what is the function. So it is sine of net 1, that is nothing but sine of 2.5. And what is the sine of 2.5? 2.5 is a positive number, hence sine of net is equal to 1. So now what is the learning signal here? Learning signal here, it is nothing but this one is the learning signal. So R is nothing but di minus OI. But what is di minus OI? Di minus OI. Di is minus 1 and OI is equal to plus 1. So if at all you move aside like this and see, di is equal to plus 1, that is here. Di is equal to minus 1 and OI is equal to plus 1. So what is the weight update formula? The weight update formula is minus 2. The weight update formula is minus 2CXI. So we have to use this particular weight update formula here, minus 2CXI. So what is the weight? So we have delta W1. Sorry, this is delta W1. Okay, I made a mistake here. It is Wi only, because this is delta Wi. It is not Wi plus 1, because actually what you get next, that will be I plus 1. But delta W, it is delta Wi is equal to C into di minus OI. So di minus OI is, d is minus 1 and OI is plus 1. So I will get minus C minus 2C X1. So this is also W1. Delta W1 is equal to this. So what will be W2? W2 will be W1 plus delta W1. So if at all we calculate, what will be delta W1? Minus 2, C is nothing but 0.1 into, this will be X1, 1 minus 2, 0, 1. So what will be this value? 0.2 minus 0.4, 0, and okay, this is minus 1, please note this minus 1, and it will be minus 0.2. This is the equation of delta W1. So we can find out what is W2. Okay, I made a mistake. This has to be minus, this has to be plus. Okay, minus 0 is as good as 0 only. Plus what you get here, that is delta W1. So if at all you find this, this will be 0.8 0.8 minus 0.6, 0 and 0.7. So this is W2. Now with this W2 we have to do iteration 2. So what is done in iteration 2? Basically you will be presenting x2 and that time you will be multiplying, calculating net to O2. So what we do in iteration 2? Sorry, not iteration 2, I mean to say what we do in step 2. Iteration 2 is after all the inputs are presented. So in step 2 what we will be doing is that we will be presenting pattern x2. This is x2, 0, 1.5, minus 0.5 and 1 and d2 is equal to minus 1. So after presenting this we have to find out what is net. So we have to find out what is net 2. Net 2 will be nothing but W2 transpose into x2. So W2 is 0.8 minus 0.6, 0, 0.7. I hope you know this is a column vector, this is W2. So when I convert it to W2 transpose, sorry this you write subscript. Okay, transpose meaning it will come as a row vector like this. And then you multiply with x2, 0, 1.5, minus 0.5 and 1. So calculate net 1. After calculating net 1, you calculate net 2. That is, what I mean to say, calculate net 2. And after that, you calculate f net 2, that is O2. And after that, you have to calculate. So what is net 1? Net 1 is minus 1.6. What is f net? Sorry, not net 1. I am again and again saying net 1, net 1. It is net 2. Net 2 is minus 1.6. F net 2 is therefore minus 1. Because it is sign of f net 2. So it is f net 2 which is minus 1. So what is d2? d2 is minus 1 and O2 is also equal to minus 1. So d2 is equal to O2. Therefore, what we can write is that W3 is same as W2 because delta W2 will be equal to 0. So, we get the same weight vector delta W3, and what is W3? Same as W2, 0.8 minus 0.6, 0 and 0.7. Is that clear? So here we get a particular step wherein both the weight, there is no weight update taking place at step 2. So we move on to the step 3. To step 3 when we move on, what we get is that you have to present pattern 3. So you present x3 and what is x3? x3 is minus 1, 1, 0, 0.5. This is x3, sorry, this 0.5 and 1, minus 1, sorry. So when you present x3 and what is d3? d3 is equal to plus 1. So we have to find out net 3, W3 transpose into x3. W3 transpose will be same as W2 transpose. And then you multiply with this, calculate what is net 3 and then calculate what is O3, that is f net 3. So the main important step here is only to calculate net 1, net 2, net 3. Rest O2, O3 is very simple. So Perceptron learning rule has got this particular advantage as compared to your other one because only you can use only Signum function for Perceptron learning rule. So the answer comes I think minus 2.1. So the sign of 1 will be minus 1. Now here what happens is that D3 is equal to 1, O3 is equal to minus 1. Hence D3 is not equal to O3. So we have to use that weight update equation when D3 is equal to 1 and O3 is equal to minus 1, O3 is equal to minus 1. So when D3 is equal to 1 and O3 is equal to minus 1, let's check what happens. D3 is equal to 1 and O3 is equal to minus 1. This one. So this one, whatever is underlined, this one. So what it is? 2Cx. So the formula is 2Cx. So the weight update, that is delta W3 will be nothing but 2Cx3. So it is 0.2 times x3, that is minus 1, 0.5 minus 1. So it will be minus 0.2, 0.2, 0.1 minus 0.2. So this will be delta W3. So we have to find out next what is W4. W4 will be W3 plus delta W3. What is W3? 0.8 minus 0.6, 0.7 plus so what will be this particular, this is 0.6, next will be minus 0.4, 0.1 and 0.5. So this is your W4. So if at all we have finished iteration 1, usually as I have told you, you have to perform one iteration unless it is specified that you have to perform 2 iterations. So if at all I minimize this, we go back to this problem. We started with iteration 1. Here iteration 1, step 1. So this is, we have done only one iteration. If at all you are asked to do 2 iterations, then what you will do is that this same steps you will repeat again. But remember, the weight, you cannot take this weight